Right, so welcome back to another video on this 5-a-day series. So this one is from the 9th of January. This is grade 6, grade 7. Obviously, first question is solving a quadratic equation. So first thing that we would do, we notice that there's a coefficient in front of the x squared term, so we're going to multiply that onto our last term. So the question now becomes x squared plus 5x plus 4 is equal to 0. Next step, obviously, we're going to have to factorize it. So 4, so that will be x plus 1 and x plus 4, which is equal to 0. We're going to have to solve this, but before we solve this, because I multiplied this by 2, we're going to have to divide this by 2 as well. So now this becomes 2x plus 1, and simplify that, giving us x plus 2 is equal to 0. So this is the factorized version of the question that we got. This is the factorized version of the purple one. Now, if you want to solve an equation, you look at the first factor. Imagine that that is equal to 0. So if 2x plus 1 is equal to 0, x would be equal to minus a half. Or you could also claim the second factor is 0. So if x plus 2 is equal to 0, that means x is equal to minus 2. So those are the two solutions of the first question. Second question says, you've got a crowd of people in which there are men, there are children, and there are men, there are women, and there are children attending a rugby match. So it is a ratio question. So the first thing I would do is I would write out the titles or the headings of the ratios. So women to men is 4 to 3. And then I have men to children, that is 2 to 5. Well, it's the same crowd, so obviously the men or the number of men in the crowd have to be the same. Problem with this ratio is when one part of the ratio we've got the men as 3, the other part we've got as 2. So let's try to make them into a same number. 3 and 2 can be turned into 6. So we are looking for the LCM between those two numbers. So that would be doing times 3, which means we're going to do times 3 here as well. So the number of children would be 5. This is times 2, which means we're going to do times 2 here as well. That means the number of women would be 8. So we want to know what percentage of the people at the rugby match are children. So I know there are 8 women, 6 men, and 5 children. So altogether, next thing in any ratio question we would find straight away is the total. So that's 8 plus 6, so that's out of a 19. If I want to find the percentage of children, that would be 5 out of 19. Because it is a fraction and I want to find that as a percentage, I would grab my calculator and then times that by 100. So let me just try doing that on my calculator. So I've got 5. I'm hoping I didn't make a mistake. Oh yeah, that's the mistake, because I felt there's something wrong. Yeah, that's a 15. So if that is a 15, then this would be it still is a weird number. 29. Have I made anything 2 and 5, 4 and 3? Yeah. Oh yeah, now I have 15 out of 8 plus 6, yeah, 14, 14 plus 15, which is 29. Yeah, still is a weird number. I thought it would become a nice number. Yeah, it is 29, and then let's multiply that by 100. So if I grab my calculator and if I pop in 15 divide 29, so my answer would be 51.7%. Yeah, I think I've done that okay. Let's move on to the next one. The table shows how long some people took to complete a crossword puzzle. we need to draw a histogram. So whenever you are hearing the word histogram, what I want you to remember is frequency is the area of the bar or the rectangle or the area of your bar that you're going to draw. So the first bar that you're going to draw is from 0 to 10. So let me explain the idea. So if I'm drawing this from 0 to 10, I have to draw a bar or a rectangle whose base would now be from 0 to 10. Obviously, that's 10 units. You ask yourself if the frequency, remember, frequency has to be the area. So the frequency of this, or the area of this rectangle, has to be 40. So you can ask yourself, what should be the height? If the base is 10, then obviously the height of that graph should be 4. So what we're going to do is, first, we've got to go from 0 all the way till 50. So let's do 0, 10, 20, 30, 40, and 50. So we first, let me see if I can zoom in. Can I zoom in? There should be some way in which, oh yeah, I can zoom in. Yeah. So the first thing that we do, we kind of write down. Now, the next thing that we know that we need to have a bar between 0 and 10, and the height of that, because I need 40 to be the area, that should be 4. Now, because we're doing frequency density, we always go up in numbers of 1, 2, 3, and 4. It is not your normal frequency. I've seen so many people do that mistake in the test. People consider, or people tend to think, this is frequency, and they draw a 40 here, thinking it is a normal frequency. So that is a one very common mistake that I've seen people make. They tend to write the frequency there and draw a normal bar chart. We're not doing a normal bar chart here. We're doing a frequency, we're doing a histogram. So frequency density obviously should go from 1, 2, 3, 4. So we're going to go 1, 2, 3, 4, 5. Obviously, I'm just hoping that should be enough. So if this is 4, then that's the height of the graph or the histogram that we are looking for. Okay, didn't quite get that straight, but earlier it worked. I don't know why it didn't work this time. Yeah, okay, there we go. So we got that one. The next one is okay, that's okay. So what I suggest is, it's always better we find the height first. So the height of this one should be 4. The height of the next one. So if you think about it, 10 to 20 is your bar, which means the height of, the base of that is 10 centimeters long. You want the area to be 85, which means the height should be 8.5. Next one is from 20 to 30. So again, that is also 10. Divide the area with the height, so that should be 5. This one is 30 to 50. So if you're doing 30 to 50, that means the base is 20 and you want a height of 30. So the area should be 30 and the base is 20, which means this would be 1.5 here. Right, so we know the area is 30. I know the base is 20. So if you do 30 divide 20, you'll get 1.5. So now if I look at all of the heights, it should go all the way up to 8.5. So what I have done here is actually a mistake. I shouldn't have done that. I should have first calculated the heights. So because it has to go all the way till 8.5, we're going to go up in twos. So 2, 4, 6, 8, and 10. So the first one would be 0 to 4. Yeah, 0 to 10 is 4. Next one is 8.5. So 8.5 should be somewhere in between the 8 and 9 mark. So we get that one there. And then that's 5. And the next one is 1.5. So where's 5? 5 is here. And then the last one is 1.5. So 1.5 would be in between 1 and 2. That's somewhere there. And that's your histogram. So all I want you to remember is, whenever you're drawing a histogram, remember the area on the inside would be equal to the frequency that is given to you in your table, and then you can then calculate. Obviously you can't change the base or the width of your bar or the rectangles. What you can change, or what you can calculate, is the height based on the area that you've got. So that's a histogram. And this one is similar shapes, similarity question. So box A, box B have similar containers. The surface area of box A. Okay, so first we're going to do area scale factor. We are doing length, so we're going to go length scale factor. I would have done volume scale factor as well, but at the moment we don't really need the volume one, so we're going to skip the volume one. So if I want to find the area scale factor is always the bigger one divide the smaller one. The bigger area here is 25, smaller one is 24. So that would be, yeah, so that would be 25 over 24. So that's my, so always remember, any scale factor that you want to find is your bigger side or bigger area, bigger volume divided by the smaller one. So that's my area scale factor. So if I want to go from area scale factor back to my length scale factor, remember area is centimeter squared, meter squared, anything squared. Length is just normal length, and your volumes would be centimeter cube, millimeter cube, all those cubes thing. So how do you go from square to normal one? You would square root it. So if you want to find your normal scale factor, you're going to have to square root the normal one. So that would be square root of 25 over 4, which is 5 over 2, and that is 2.5. So you found out your length scale factor, which is 2.5. Now you're going to find the length of boxes. So ask yourself, am I making a side bigger or am I making it smaller? If you're making it smaller, you would divide by your scale factor. If you want to make it bigger, you would multiply by your scale factor. So because you were doing a division here, this would be divide by 2.5, which is your length scale factor, and your answer would be 4 centimeters. And that is the end of the 5 questions for today. I hope this makes sense, and I'll see you in another video.